In this video, we are going to go over equivalent fractions. We'll touch on what equivalent fractions are, how you find them, and why they are useful. Make sure you watch until the end, because we're going to go over lots of different ways to look or solve for equivalent fractions. Let's get started. First, let's talk about what an equivalent fraction is. Well, if you looked at the definition of equivalent, you would see that it means equal in value. So an equivalent fraction would be fractions that are equal in value. But when we say equal in value, we don't necessarily mean that the fractions are written the same. We are talking about fractions with different numerators and denominators being equal. Let's go over a quick visual example to show this. Remember, a fraction represents a part or piece of a whole when that whole has equal parts. In the picture shown here, we have 3 bars. They are all equal in length, and they have the same amount that is colored. In the first one, you will see there are 3 boxes. If we decided to color 2 of those boxes, we would say the fraction of colored boxes is 2/3. We write that as 2 over 3. 3 is written as the denominator, the bottom number, because it always shows the total number of parts. And 2 is a numerator, top number, represents the portion or pieces. Here's a quick tip. If you're having trouble remembering what is the numerator and what is the denominator, think of this. Numerator starts with N. Think of north. Looking at a compass, it's up top. Denominator, D, stands for down. Back to our example. So the second line has a total of 6 boxes. We put down 6 as our denominator, and if we want to color the same amount as our top line, we would end up coloring 4 boxes. Let's look at the third line. The total number of boxes we have is 12. We put that in as a denominator, and if we want to color the same amount as the first 2 lines, we would have to color in 8 boxes. Now, do you agree that all the colored portions are equal or equivalent pieces of the whole in each line? Yes, but the fractions are written differently. We have 2/3 on the first line, 4/6 on the second line, and 8/12 on the third line. All of these fractions that we just wrote down are equivalent fractions. Their numerator and denominators are different in each example. However, they represent the same fraction or portion of the whole. So now that you understand what an equivalent fraction is, let's move on to how you find equivalent fractions. Let's look at our first 2 fractions together first. We had 2/6, 2/3, and 4/6. Did you notice anything about these numbers when they were placed next to each other? Both the numerator and the denominator are double in the second fraction. Another way to look at it is this. 2 times 2 equals 4, and 3 times 2 equals 6. Have you ever heard of the identity property of multiplication? The identity property of multiplication states that when you take any number and multiply it by 1, you will always get that original number. In addition to that, the identity property of division states that any number divided by 1 will also always equal itself. So, 22 times 1 will always equal 22. 465 times 1 will always equal 465. 4 divided by 1 will always equal 4. But what does that have to do with equivalent fractions? Well, when you look back at our fractions of 2/3 and 4/6, you will notice that they are both multiplied by 2. And if you have 2 over 2, that equals 1, right? Anytime you have a numerator and a denominator as the same number, that is the same thing as one whole. Look at these fractions with the same numbers below, with the numerators and denominators the same. All of these fractions are equal to 1. What this is saying is that when you multiply or divide a fraction by 1, you will get the same number. Or when you multiply or divide a fraction by another fraction equal to 1, you will have the same fraction. So that brings me to the point of how do you find equivalent fractions. If you were to have the example of 5 over 10 and were told to find an equivalent fraction, how would you go about that? Well, there's lots of possibilities, right? Let's focus on finding equivalent fractions using multiplication. Let's take 5 over 10 and multiply it by 2 over 2 as a simple example. Remember, 2 over 2 is equal to 1, as the numerator and denominator are the same numbers. When making equivalent fractions, keep this in mind. What you do to the top, you must also do to the bottom. 5 times 2 equals 10, and 10 times 2 equals 20. So, 10 over 20 is an equivalent fraction to 5 over 10. Let's take that same example of 5 over 10, and let's multiply it by 6. Multiply the numerator times 6, and the denominator times 6, and you have 30 over 60. One more example. If you were asked to find 3 equivalent fractions for 2/5, how would you go about that? The easiest way to do that is to multiply the numerator and denominator by the same number. We can start with 2 first. 2 times 2 equals 4, and 5 times 2 equals 10. So 4/10 is equivalent to 2/5. Let's pick a different number. How about 11? 2 times 11 equals 22, and 5 times 11 equals 55. So 22 over 55 is equivalent to 2 over 5. Finally, let's take 8. 2 times 8 equals 16, and 5 times 8 equals 40. So 16 over 40 is equivalent to 2/5, but is also equivalent to 4 over 10 and 22 over 55. So, now that you know how equivalent fractions work, let's look at a few examples to help us apply what we just went over. Here I show you 4 fractions, and we will need to fill in the missing numbers to make them equivalent. In the first one, we have 1/2. 1/2 equals what number over 20? Well, 2 times what number equals 20? The answer is 10. So if we take 1 times 10, our answer would be 10. So 1/2 is equal to 10 over 20. Our next example, 7 over 8 equals what number over 32? 8 goes into 32 4 times. Since 8 times 4 is 32, we take 7 times 4 and get 28. 7 over 8 is equal to 28 over 32. 4 over 5 equals 16 over what number? 4 times 4 is equal to 16. 5 times 4 equals 20. So our equivalent fraction is 4 over 5 equals 16 over 20. Last one. 2 over 9 equals 22 over what number? Well, 2 times 11 equals 22. So 9 times 11 would be 99. 2 over 9 is equivalent to 22 over 99. Now, let's look at some examples a different way. Here I show you 2 fractions, and I want you to tell me, are they equivalent? The first example, 1 over 9 equals 7 over 63. We determined that they are equivalent because 1 times 7 equals 7, and 9 times 7 equals 63. So yes, they are equivalent. Our next example, 14 over 25 is equal to 28 over 75. Well, let's see. 14 times what number equals 28? That answer would be 2. 25 times 2 equals, well, it's not 75, it's 50. So these 2 fractions are not equivalent. 6 over 10 equals 42 over 60. 6 times what number equals 42? That would be 7. 10 times 7 equals 70, not 60. So these fractions are not equivalent either. Last example, 8 over 14 equals 24 over 42. Well, 8 times 3 equals 24. 14 times 3 equals 42. So yes, these fractions are equivalent. We have looked at solving for equivalent fractions and also evaluated sets of fractions to see if they are equivalent. What I want to go over now is another way that you can double check your answers to see if the 2 fractions are equivalent. Let's look at the following equivalent fractions. 1 over 9 equals 7 over 63. We know they're equivalent because 1 times 7 is 7 and 9 times 7 is 63. By using cross multiplication, we can validate or double check our answers to make sure they are correct. What I mean by that is 1 times 63 equals 63, and 9 times 7 equals 63. Let's try another one that we know is equivalent. 6 over 10 equals 60 over 100. We know for a fact that this is equivalent because 6 times 10 equals 60, and 10 times 10 equals 100. By cross-multiplying both ways, we see 6 times 100 equals 600, and 10 times 60 equals 600. Pretty sweet, right? Well, what if I gave you the following fractions and told you to use cross-multiplication to find the missing number? Let's take 5 over 25 as an equivalent fraction to 4 over what number? Well, 25 times 4 equals 100. So what number times 5 equals 100? That would be 20. So we can show that 5 over 25 is equivalent to 4 over 20. We went over a ton of information in this video. If you found it helpful, give me a thumbs up and don't forget to hit subscribe. If you would like additional practice problems, head on over to improvedmath.com and check out my free resource page with additional examples and answers. Thanks for watching.